Hi everyone, you are watching the video for our class project presentation from Group 6 in Financial Programming and Modeling class at UConn. My name is Pei Wang. I'm from China, and look at this picture. It is of our group members. The guy on the left is Zhenqian Li. He's from Guangzhou, China. And we are both first-year graduate students, major in applied financial mathematics at UConn. For this class project, we choose our topic as minimum variance portfolio and Monte Carlo simulation on selected stocks returns. We have divided this presentation into three main parts: objectives, methodology, and results. So, for this class, we have learned many useful programming skills for financial analyzing with MATLAB, Python, and R, and we want to apply the knowledge to complete a comprehensive project using Python and Quantopian with these following objectives. First, retrieve selected stocks data from Yahoo Finance for a certain period. Second, establish a minimum variance portfolio based on the stock's returns. Third, run backtesting on Quantopian for our portfolio and compare it with the stock market. The last one is to develop Monte Carlo simulation on selected stocks returns and compare it with their real performances. And for methodology, the first knowledge we use is minimum variance portfolio. Portfolio variance is a measurement of how the aggregate actual returns of a set of securities making up a portfolio fluctuate over time. So the minimum variance portfolio is a portfolio of individual risky assets that, when taken together, result in the lowest possible risk level for the rate of expected return. The name of the term comes from how it is mathematically expressed in Markowitz portfolio theory, in which volatility is used as a replacement for risk, and in which less variance in volatility correlates to less risk in an investment. And so generally, in minimum variance portfolio, we aim to minimize this term here, and the letter C is a covariance matrix of the returns, and for W, that is the expected portfolio return, whilst keeping the sum of all the weights equal to 1. The sum should be 1. And that is method we used to do the portfolio. Another term is efficient frontier. The efficient frontier is a set of optimal portfolios that offers the highest expected return for a defined level of risk or the lowest risk for a given level of expected return. And all other portfolios below this curve, you can see from this graph here, these black dots are individual assets, and this blue curve is the efficient frontier. And this is the minimum variance frontier we want to get. All other portfolios below this curve is called suboptimal portfolio, because at the same risk level, those portfolios gave a lower return comparing the portfolios on the efficient frontier here. Notice that the minimum variance portfolio, or called global minimum variance portfolio, is on the end point of this curve, because at this point we get the minimum variance, and that is the definition implies. And the last methodology we used is Monte Carlo simulation. Monte Carlo simulations are used to model the probability of different outcomes in a process that cannot easily be predicted due to the intervention of random variables. In our project, we used random walk as method to simulate the stock price trend and compare it to the actual stock prices. And now we move on to the main part of our project with codes and results. The first thing we do is to retrieve data from Yahoo Finance. We first selected 8 different companies' stocks to get our data, which is Twitter, Apple, Facebook, Google, Microsoft, Boeing, Walmart, and General Motors. We used Python to retrieve the data for stock prices. Luckily, there is already a library in Python called Yahoo Finance. We first downloaded this library in our computer, and once we have installed the Yahoo Finance library, we used the code to get the data for us, with a time interval from January 1st, 2016 to June 30, 2016, this year. And here, on this PowerPoint, it is just a portion of the code we use because we have tried with 8 different stocks, and here it's just for one stock, and we save the stock prices into Excel file. After that, we combine all the adjusted close prices for these 8 stocks and put them in one Excel sheet as saved as stock prices for further reference. And now we move on to the coding part. I will introduce my teammate, Zhentian Li, to introduce the following parts for our presentation.
Okay, next I will introduce the part of minimum variance portfolio. So before we try to find out the minimum variance portfolio, we will obtain the efficient frontier of our portfolio first. The first step is we will create random weights by the following function, as you can see in the first picture. Then we will assign these random weights to our portfolio and compute their corresponding returns and risks. And after we obtain the random portfolios from the functions, we scatter it in a plot and we will see what happens. That's the second picture in this screen. So we can see that there are a lot of possible portfolios with different returns and risks. To be more clear, we will draw out the efficient frontier with a red dot line. As we can see from the plot, each dot represents a portfolio with their corresponding return and risk level. The red dot line, as shown, is efficient frontier. All portfolios on the frontier are optimal in a given risk level. So what we need to do next is to find out the portfolio we aim to achieve, the minimum variance portfolio. In this picture, the following Python function is defined to solve the quadratic programming problem we mentioned before. We aim to find out the portfolio with minimum risk level from all the random portfolios and obtain the corresponding weights. We notice that the input parameter is a returns vector, and the only constraint we need to set is that all weights must sum up to 1. And by running this function, finally, we will obtain the minimum variance portfolio weights from this function. And the result is shown here. The next part is backtesting. So after we calculate the weights of the A stocks in the portfolio, we use the following code to run the backtesting on Quantopian. We assign the weights and set the function to rebalance the investing portfolio 1 hour after market opens. At last, we also called another function to record and plot the profit of our portfolio at the end of each day. And the resulting graph we got from the backtesting is shown in this screen. So, from the graph, we can tell that our portfolio has a great performance during the period we selected. It has a total return rate as 21.5% with volatility 0.25, which means our portfolio is pretty stable. And the Sharpe ratio is 1.82. For Sharpe ratio, it is a risk-adjusted measure of return that is often used to evaluate the performance of a portfolio. After calculating the excess return, it's divided by the standard deviation of the risky asset to get its Sharpe ratio. The idea of the ratio is to see how much additional return you will receive for the additional volatility of holding the risky asset over a risk-free asset. The higher, the better. Besides, the total return curve is always above the benchmark return curve. The method of Monte Carlo simulation was briefly introduced in this class, but it is widely used in the financial world. So we want to have a try and see what we can get with this method. From previous part, for establishing the minimum variance portfolio, we noticed that the Walmart stock has an especially huge weight than any other stock in the portfolio. That is because the main idea of medium variance portfolio is to reduce the variance among the portfolio. It might assign huge weight on some certain stocks for this purpose. Since this portfolio is mainly built up with Walmart stock, we decided to develop simulation with Monte Carlo method for this pick stock. And here is our Python code we use for the Monte Carlo simulation. After running this code, we plot out the graph of real stock prices and the simulated prices for comparison. From the graph, we can see that the trend of these two price charts are very similar. Although the fluctuation of Monte Carlo simulation is less than the real price in this scenario, it does not mean that the Monte Carlo simulation will produce a relatively stable result for us. What we see in this graph is just one case for simulation. As we mentioned before, Monte Carlo simulation we used in our project is based on random walk. So the results obtained by Monte Carlo simulation is various. Here we just present one case for comparison. In summary, we use A stocks to create a minimum variance portfolio and compare its performance with real stock market by backtesting in Quantopian. In addition, we use Monte Carlo's method to simulate prices for a certain stock. As expected, the portfolio's performance is much better than the benchmark, and that's the reason why we need to create a portfolio. Because by creating a portfolio, we maximize the expected return and minimize the risk according to our risk tolerance. And that's all for our project. Thanks.